All right. So for log management, take a look through here. We talked in the past about some of the incidents that you guys would see from malware infections, phishing, denial of service attacks, insider threats, and unauthorized access, along with breaches and some other ones here. When the event itself occurs, and it's going to refer to anything that's an observable occurrence or indicate some kind of incident has been recorded in the system logs and the system tools. So events can range from a routine or benign activities to potentially malicious and security relevant events. You guys will see the different types of events. It could be any of these that would pop up and raise a flag in your SIEM. From the logging perspective, this is again where it's key to have everything from everywhere in the network and the system go to one centralized log management system. And it's not enough to have something like a just a giant log server or an elk stack or something like that. You actually need to be able to correlate that data, and that's the big importance. And a lot of times when I get out into networks, that's the biggest issue is timestamps and log data. A lot of times people don't stand up their NTP servers internally, and so you want to make sure everything inside the network points to some NTP server inside the network. Now that time server then can go out to the internet and get updated time, but as long as everything inside your network is pointing to the same device, in theory everything should be synced up on that side of it. But when I've done a lot of troubleshooting and things with different companies, that was the biggest issue is the logs were all out of whack, and therefore you're spending more time trying to correlate data that just won't correlate. So it's really important in getting that all set up so that you generate logs and actually push them to one location. And then something like this with the SIEM, in this case, we've talked about Splunk and a few other ones. They will not only correlate the data between all the different things that are being logged, but then you can see it in one giant view. So you can say, hey, traffic is going up at this point in time. I'm also seeing suspicious login activity on this PC, and our firewall is acting crazy. It's producing a lot of logs and random hits from China, something like that. That's a great example of what you typically see in these. And I have to go through these same type firewall logs, etc., and correlate them in between there. As a matter of fact, I still do that for a company where I manage all the firewalls out there. So every day is basically going through these, trying to get them all together, and then seeing if there's anything that would raise any kind of suspicion. So different sources of logs are going to be your operating system logs, clear down to the Windows event logs and syslog. This will be all your endpoint protection. Your different applications will have logs, things like web servers for Apache, Nginx, database, etc. On the security side, you're going to have all the authentication logins. This could come from your Active Directory, as you see over here, but you could also have just intrusion detection system logs or intrusion prevention logs all coming back, your firewall logs, and then, of course, your AD. What's nice is once all these logs get in and you can kind of go through them, you can also start to use machine learning and things like that to be able to correlate that in real time. And that's really where the new systems are really taking off. Everybody wants to use the term AI, but it's really just being able to correlate this information in real time versus having to manually kind of search everything out. And so audit logs, network device logs, your endpoints, your cloud service, and your database. You also need to grab your DNS server logs. This one's actually more important than most people realize. Your IP addresses and things like that, while are still relevant, a lot of things are done through DNS now, particularly all of your phishing and malware attacks. Everything's kind of going over DNS query logs. You can even package malware packets in DNS queries, because a lot of times in firewalls and such, we just wide open 53, right? We need to be able to get our DNS services, so we let it go. But more sophisticated attacks are actually taking that tunnel that you're opening up and pumping in malware through those requests. This is also important if you have a malware type attack where on the far side, you have people attacking and it's randomly changing the DNS entries so that it doesn't get flagged by the firewall. That way you can't just go block xyz.com. You actually have to block a whole series of it. And a lot of times there's no way to do that in real time. all your virtualization logs, your access system logs. This one's more there again, just had a bid on another company come in and really locking down their physical access side. This is becoming, it seems to be more apparent in more of the businesses where they're going to access card systems. They're not as expensive as they used to be. And they will tend to tailor in with a lot of other equipment they're doing. So a great example of that's like Ubiquity, where they've taken their networking, their Wi-Fi, et cetera, and they now have the access system side to help integrate that all into one management system. Application performance tools and going through there. So the logs themselves are going to serve as a valuable resource to kind of go through as professionals and monitor, detect, and respond to that, particularly when we have that security incident detection. So this will be when a SOC analyst detects something in a firewall or a sudden increase in connection refusals on a particular IP. And it may suggest that a potential denial of service attack is happening, leading to the analyst going a little deeper. At that point, a company's SIEM system will scrutinize user login records and flag instances where the employee logs in from an unfamiliar location or maybe during odd hours, indicating a possible breach or unauthorized user credentials. Forensic analysis, this is kind of the fun CSI part of it, where following that security incident, logs are crucial for this forensic analysis to understand the timeline of events, identify the point of entry, and then determine the extent of the compromise. This really is the fun part, and you guys will actually get a chance to kind of go through these type of attacks. Suspicious behavior is when an employee attempts to access sensitive files beyond their job role and can be detected early on by monitoring authentication logs. Compliance monitoring, this is going to provide a record of security related events and access control logs. This one's becoming more and more prevalent for cyber insurance and making sure that you have like two-factor authentication and all those things are being logged so that they can try to pin that back to where that's coming from. Your incident response is, getting an alert from an intrusion detection system, reviewing those logs and understand that nature of attack, network traffic analysis, malware detection, and our insider threat. And this one is where you're starting to see an employee with legitimate access is trying to download a large volume of sensitive data, raising any kind of suspicions of potential data exfiltration, aka just sending data out. And this can easily be revealed by those monitor logs. So log format, this is probably the most complicated portion of logging. If you guys have ever played with logs, everybody has a different format. One of the most common ones is syslog. But you use a sign to correlate what kind of data is coming in. So you can take a generic log format, and then what you're doing is capturing the different pieces. So for example, some may have critical warning, error, info, etc., as the first piece of the log, and then it has the today's date, which is in a different timestamp, and then you may have source IP and things like that coming through there. You're going to have to adjust what comes into the system for every single device that comes in there so that it matches up the columns correctly. That's where having a nice standardized log format is handy, but not all devices will end up doing that. So timestamp is going to be the big piece there. Any kind of event type or ID, again, this would be like your logging, warning, etc. Your source IP and some kind of port, any kind of user information about that event, what action was taking place or operation, the status or result of that action, and then any kind of device or system identifier that generated the log itself, and any kind of event description. So local log management is beyond the context of just a SOC, refers to the practice of collecting, storing, and analyzing logs generated by the system, applications, and devices within the network. So you'll have log collection. Local log management involves a collection of logs generated by various components in the network, including our servers, etc. Storage at the source, where logs are stored locally on the devices or system that generated them. This local storage helps maintain a historical record. It also gives us a chance to see if the end user is manipulating the logs. So if the attacker is coming in and then changing the logs to cover their tracks, they have to change them not only on the end device, but then they would have to change them at the SIEM level too. And that's great, because if the SIEM says it's one thing and the local source says, nope, everything's fine, somebody probably tweaked that log file along the way. Analysis at the source, basic analysis of the logs being performed locally to identify immediate security issues or anomalies. These local analysis may involve setting up any kind of rules or triggers to generate alarms, etc. Remediation, reducing our network traffic by analyzing and storing logs locally. Organizations can reduce the volume of log data that needs to be transmitted over the network. That is one thing I have run into when doing this. It's great to have as much logging as possible, but you can also generate a lot of traffic just basically monitoring your network. In most cases, you can generate more traffic than your network is actually generating on its own. Isolation and containment, making sure that we can keep that local log management for any kind of affected systems, limiting the broader impact of the network, resource utilization, compliance, etc. So by having centralized log management versus the local log management, and you should probably have a combination of both, but centralized is going to give us any kind of aggregation for log management, storage, and then normalization and standardization. This is where you can make sure you're taking logs from a bunch of different systems and standardize that log data to ensure any kind of consistency within the SIEM software. So this one's the biggest piece of it all is normalization and standardization. Plus, you can start to do the correlation, that fun word that we said over and over and over, real-time monitoring, and then alerting and notification. The real deal is being able to search and query and then find the query from a bunch of different systems out there. And then be able to do any kind of forensic analysis and log straight on the centralized environment, where you can do it at the end log side, but you'd have to go to every single device, pull the logs, then set them together. A lot of times in the old days, we did that with like Notepad and multiple tabs. Being able to try to figure out in the logs and then scroll down all at the same time. SIEMs and any kind of centralized log management really takes this all out. So our logging best practices are going to be defining any kind of logging policies. This can be on any end device that we go through there. We're going to protect that log integrity, aka ship it off to a centralized, but also keep a local one there as well. Make sure we're capturing all the relevant information, send it off to the centralized, standardize all those log formats, implement RBAC. RBAC is going to be your role-based access controls, and then include your timestamps of everything that comes in there, encrypt any log data in transit at rest, and then our retention that comes through there. So this one's also important. Find out who's accessing those logs. If they're able to change it on the local system, if they've compromised enough all the way down, they may be able to compromise that central logging as well. These are all the tools you're going to use for those logging and things in there. So SIEMs are going to be your biggest one. And these are a comprehensive solution that centralizes and correlates that data. The biggest one out there is Splunk, but Splunk is extremely expensive. And I'm assuming most of you haven't had a chance to play with that unless you were at a bigger company. Logarithm is a pretty handy one that will do that as well. A lot of these are going to correlate together and work together. So if you have ever downloaded the software for Security Onion, that's essentially a collection of all these tools into one type of operating system. There's several of them out there. Security Onion is just one of the more popular one. Has anybody played with Security Onion?
I don't think so.
Nope.
So if you guys have a way of doing virtual machines and stuff on your laptop, etc., I would encourage you to go out and grab a copy of Security Onion and deploy it. Whether you want to deploy it on your laptop, if you got a home lab, something like that. It's a really, really slick way of having all these tools together. You'll get everything from network visibility, host, intrusion detection, honeypots, log management, and case management. So what it's going to do is use a bunch of open source tools that are available for doing all of this stuff in a SOC. I strongly suggest, if you guys got a little home lab or even a home network, set this up, kind of have everything funnel to it, and you'll get the real basics of it with free content. It doesn't cost anything to go through there. And you're going to have a bunch of different tools that are going to generate those things for you. So And the labs that you will do in the CYSA stuff, those are all going to be Security Onion based. And so being up to speed on what Security Onion is will at least help you understand what log management is. All of them are different. So ones that are Splunk versus an Elk stack versus, Elastic stack, etc. They're all going to be a little different in the syntax you use for searching. But when it comes to Splunk, and we're a Splunk university as well, so if you guys want additional Splunk training, you find out in your job you need additional Splunk stuff, I've got access to a lot of that. But Splunk is another one that you can actually go download a free software on that side of it as well. There's a free trial for that one. And I can even get you guys additional licensing for that. And you can kind of play with being able to go through the syntax. And there's some pretty nice training in here. If you go to training and certification, and then you'll see a course catalog. And again, we have access to a lot of these coming out of here, but some of them you can do for free right off the bat. This intro to Splunk, using fields, etc. There's entire jobs where all you have to do is know how to use the search tool in Splunk. And then there are $100,000+ paying jobs just to know how to do the syntax in Splunk. And again, you don't have to live in that company to do it. Almost all of it's done remotely. So Splunk is one of the big ones. Now Cisco bought it, which can be good or bad, depends on how you see it and what they end up messing up, as far as I'm concerned. A lot of times Cisco will buy things and then mess up the product by adjusting how they use it or the licensing or et cetera, et cetera. So Splunk's good there. We do have a Splunk education license, like I said before, so I can get you access. But I encourage you to start with Security Onion. This is a great place to learn the basics, understand how dashboards work, understand how you build a case from start to finish. Again, the labs that we're going to do are going to kind of help you through that kind of thing, as it's really important to make sure you create tickets and be able to track that in the future moving forward. All right, let's get back to the right one here. So Splunk and your syslog ng. So now we're going to get to our collectors, right? So SIMEs are the over-encompassing everything that's going to be in there. Your collectors are going to be what collects logs from various devices all over the network in various locations, and then forwards them out to a centralized repository or out to the SIME itself. And so you'll have syslog ng, which is the next generation of syslog, and winlog2b. You'll also see some other log collectors out there within the Security Onion stack. Then you need a way to do any kind of analysis on these and visualize them. So that's where you'll see tools like Kibana and Grafana. These are going to be nice graph systems where you can see what's going on at any given time. And then your endpoint detection systems, this is where you're going to have these installed out there on the virtual machines or your laptops, desktops, etc. And of course, this is where you have the famous one, CrowdStrike, where earlier this summer, they pushed an update and it caused some issues on all the end devices. Carbon Black is another big popular one. Again, for gaining endpoint detection logs. You'll also get ones out there like Sophos. For example, here at Fort Hays, we use Sophos for this purpose in collection of logs and endpoint detection. Security firewall stuff. So this could be your Palo Alto Networks panoramas, your Cisco's, your Sonic walls, your OpenSense, PFSense, etc., just capturing logs off those devices. And then if you do anything in the cloud, you could do Amazon's CloudWatch or even Azure's Monitor, kind of sending things again back up to the SIME. Your database monitoring, you have Impervia, SecFear, and these. I haven't done a whole lot of this side of it, I'll be honest, on the database activity side. Let's see. Application performance monitoring tools. This would be like New Relic and App Dynamics. Again, a little bit outside of my wheelhouse on doing application performance testing. This is very much in there. So intrusion detection and prevention, Snort and Suricata are two really big ones. Those are the ones that you'll see in Security Onion. Snort was originally developed, and there's gone through a couple different names as it's gone through there. But Snort, if you can learn to write the different rules and things within Snort, then that will apply to several different pieces of software. So because this is open source, Other pieces of software are built upon that, including Saracata. Saracata would allow you to do like layer 7 detection. So if you guys have taken my Palo Alto class, and if you haven't, you're probably taking it in the spring, but a Palo Alto device can allow us to not just see that we're doing port 22 traffic, or that's a bad example, port 80 traffic over a firewall, that what's actually going over that port 80 is realistically web traffic and not something else being masked under port 80. And that's what all next generation firewalls do. They used to call it deep packet inspection, et cetera. Now it's just next generation firewalls. Saracata is a way to do that with things like pfSense and OpenSense. Palo Alto is extremely expensive on their side of it, but you will soon find out why it's expensive, because of the niceties they have baked in versus something like Saracata that you have to kind of tweak and adjust. Let's see, file integrity monitoring tools. This will be things like Tripwire and OSEC. This is just making sure that we can trigger alarms on any file related activities. All right, and that's the back end of it. Understanding those log formats is going to be really essential for parsing and extracting variables coming out of there. So you're going to have formats like syslog or even JSON, and then you have to be able to adjust those back to a centralized section. Yeah, so the gist out of this one is really getting used to that log management side. This is something that everybody overlooks, or they wait for the longest time to get set up. Really try to get some logging up on your guys' side. If you got a test network, play network at home, go grab Security Onion and then kind of work with the labs to see if you can get everything on your network at home to send the logs to one central location. And just doing that activity alone, you're going to learn a lot about your network. You're going to learn a lot about how everybody does everything differently. All right. Anybody have any questions on this intro?
I kind of did, but it's very specific and niche. But is there, because I know you mentioned Security Onion, and that's great, but is there like an offline sort of simulated version of that, or like any log management software? Because I think university will not like me trying to forward all the logs to my laptop.
Um, Offline, so your best bet, are you talking about like in your home lab?
Well, yeah, just to, because I live on campus and I want to like mess around with something like Security Onion just to get better into log management in general.
Yeah, so
But
your best bet to just get started in some of that is to do something where, if you don't have a virtualization server of some sort at like maybe your dorm or something like that, where you have a bunch of VMs or any kind of network activity, is just do that. You'll have to recreate that network on your laptop in that virtual network.
yeah,
So if you set up Security Onion in there, you could even, there's a way to do that with even like Packet Tracer, right? Where you could have those Cisco devices and Packet Tracer send those logs out. And that would allow you to do some log generation, but it's doing it all on a host only network. So it's not actually going out across something that would affect campus, that you could actually generate it internally and then send those logs to that Security Onion instance. So
okay.
that would work. And if you happen to come by sometime here next week, I can help you kind of get that all set up. We'll definitely have those type of environments out here on NetLab as well, where you have a nice sandbox network and you can jump in and generate logs and have some fake logs and things like that, so you can trial and go through. And then out here at the Cyber Institute, that's one thing that we're going to do there as well. So that's one project I kind of had slated here towards the end of the semester, if we can get to it, this quote CTF. That was either going to be me setting up a capture the flag event for you guys to do as a final assessment, or I'm planning on having you guys set up the SOC for our corporate network that we're building out. It's kind of a fake dummy corporate network. I have some guys right now building out servers and devices and all that kind of stuff on it. And then I wanted this class to be able to go in there and say, okay, we want to collect logs from everything. Let's send that out to a Splunk instance, right? Because we have a Splunk license. But we can also forward those same logs off to something like Security Onion. So you get to see both and be able to compare both. And then for you virtual students, you'll still get the same way of doing that. You will just come in through NetLab, which will put a virtual machine that is actually on that corporate network. So you guys it'd be like an in terminal, as if you were physically here with a laptop.
Yeah, just let me know what office hours you have
Mhm.
in the future, and I'll definitely come by and we can try to get that figured out.
Yep. Particularly on these weeks when you guys are doing these labs, that's when we're going to really try to wrap up all the end devices to get us started for this fall semester. And then I'm going to get you guys some remote access so that you can take what you're learning in these labs and actually do this on a live network and be able to pull everything together and not trip over one another, but you guys can all kind of work through there and see what it does. So what would happen is you would do a NetLab pod type instance, and that may have a Security Onion and your client machine there. And then you could go out to these other devices. I'll give you IP addresses, and you add your Security Onion's IP address as a forwarder. And then when it sends log to it, you should be able to start collecting logs and things like that.
Okay. Sounds good.
The end goal is instead of this CTF to me is kind of a backup plan. The end goal is that you guys would jump in here, and then for the challenge lab is I would have you guys jump in the environment, and then I would start doing something weird on the network and seeing if you guys can actually detect what's going on and capture that incident.
Yeah, that seems cool.
We may get there this year, but I'm trying for that. That's my end goal. But that's the goal for everything now that we have this institute, is to be able to do just that. That your guys' capstone event is not go figure out what was already there, but me actually actively attacking something and seeing if you guys can figure it out.
Yeah, that seems really interesting, actually.
All right. Cool. Well, that's all I got for today. Stop the recording.